A new way to beat human fungal pathogen Candida glabrata. I am Debarati Mondal from ICGB New Delhi. Have you ever imagined a constant battle between health and harm like a never-ending tug of war? Let me share a story where the rivalry is as old as life. On one side, we have pathogen, always changing, never stopping, constantly finding new ways to take the advantages. On the other side, we have drugs and medicine, standing as strong defenders, continuously evolving to face the new challenges. This is a story of survival, resistance, and resilience written anew with every vessel. Now, to look deep into such invisible battle, my PhD work focuses on one of such human fungal pathogen, Candida glabrata, which present as commensal organism in healthy human gut. But when our immune system is weak, this fungus attack and cause trouble, being an opportunistic pathogen. And the disease caused by the fungus known as candidiasis affect skin, nail, mouth, genital area, and all over the body in the bloodstream. So collectively we can say this fungal infection doesn't solely depends on fungal pathogen, rather host immunity plays a significant role to the disease outcome. Now, while discussing strength about this fungal pathogen, it is important to know what are the medicines available around us to fight back. So, there are several commercial drugs available, but long-term use of these drugs leads to toxicity and resistance to the human host. So, we thought, can we find a strategy which will target fungal pathogen as well as boost host immunity? Additionally, can we explore some plant-derived bioactives as the history of traditional medicines may provide insights into the safety and efficacy? So in my PhD, I identified and purified plant bioactives from Tanmula plant called chebulagic acid and chebulinic acid, which show strong inhibition against Candida glabrata cells. Now to understand the mode of action, we did transcriptomics and observed the upregulation of iron uptake genes, which is regulated by master regulator AFT1. Further, we found these two legitimine compounds mainly act as a iron chelator that grabs most of the free iron in Candida glabrata cells and leads to cell death. Further, when we dig deeper into the molecular mechanism, we found this AFT1 mainly coordinates with another important protein, mediator subunit 2, to regulate the expression of iron homeostasis genes. And this mediator subunit mainly acts as a postman which transfers the signal from the transcription factor to the RNA polymerase 2 to initiate the transcription. Further, besides the molecular mechanism, we checked the cytotoxicity and we found there is no such effect in mice cells, and immunophenotyping data also suggests that these two legendary compounds may enhance the innate and adaptive immune responses in mice cells. So collectively, we can say the compounds identified from Tamla plant work as a dual action remedy. In one hand, it inhibits the growth of Candida glabrata cells, and in other hand, it strengthens the host immunity. Thank you.